Go, start.
Alright, so our first problem we got is number 4, and what we're trying to find is the equation of a plane that contains the line of intersection for plane 1 and 2 while it's perpendicular to plane 3. So we already know that for plane 1, our normal vector for this is just 3, 1, and negative 1, which we got right here. And for plane 2, we know our second normal vector is negative 1, negative 1, and 2, since we just look at the constants in front of the variables. So the question says that we're trying to find a line, the intersection of a line between these two planes. And we know that if we cross the normal vectors, normal 1 and 2, we could find that intersection. So we crossed normal 1 and normal 2, which gave us our resultant vector, which is the intersection of our line. So, and we also want it to be perpendicular to plane 3. So we also know that whenever we cross two vectors, it results into a perpendicular vector. So we know that from our resultant vector, we want to cross it with our plane number 3 normal vector, which is just negative 1, 4, and negative 3. So we just crossed our resultant vector with our normal 3, which we got 23, 5, and negative 1. After we found out our normal vector, we have to find our x1, y1, and z1, since we already found our normal vector for the equation of a plane. So in order to find the points on the lines that intersect for plane 1 and 2, we have to set up a system of equations to see if it makes them true. So first we have 3 variables, so we're able to let one variable equal to 0. So we want to choose the easiest one. So I see that if we let z equal to 0, it'll cancel out, and when we add them together, equation 1 and 2, the y's cancel out as well, and we're left with 2x equals 6. And we could just divide the 2 and the 6, which gives us x equals 3. And from that point, from x equals 3, we could either plug in to the first equation or the second equation. So let's go with our first equation. We know that 3 times 3 equals 9, and we're trying to find what our y value is. So we know that this is 9 plus y minus 0, since we let z equal 0 earlier. So we want to try to get y alone. So we're going to subtract 9 to the other side, which gives us negative 5, which is our point is 3, negative 5, and 0. But just to make sure that this satisfies the second equation, we're going to plug it in and see if this equals 2. So negative 3 minus negative y plus a minus equals a positive. So negative 3 plus 5 and 0 plus 0, this equals 2, because negative 3 plus 5 equals 2. So we know that our point is on both lines. So after that, we just have to plug in. We have to plug in our x1, y1, and z1 into our equation of a plane. Which when we plug in, it's just going to give us x minus 3, which is our first point, y plus 5, because we know it's a negative. So a negative times a negative equals a positive. And then we know that z is a 0, so we just have a z by itself. And now we want to dot our normal product that contains the intersection of the first and second plane and is perpendicular to the third plane. So we dot product them, we get out this, and then we just have to solve. We just have to get our variables on one side to match our equation of the plane, which is just going to be a times x plus b times y minus or add c times z equals whatever, which we got 23x plus y minus z equals 44. And that's how you go about approaching this problem.
Perfect.